Good afternoon to everyone. This is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. I am very happy to share today our video lecture on fundamentals of spatial filter. So, as it is one of the topic which we are concentrating towards to give the importance of this topic, which we develop the image processing, such a image processing application point of view, towards to get the knowledge about this topic in aspect of to define such a fundamentals of spatial filter that we'll go through one by another, say, by the help of simple slides. Okay, so see here the meaning of spatial filter is a technique actually. Being it is a technique used directly on pixel of an image. Okay, mask is usually considered to be added in size so that it has specific center pixel. This mask is moved on the image such that the center of the mask traverses all the image pixels. So that image contains a number of pixels. So coming to the once we understand the meaning of spatial filtering, where we can apply this, then it can also be classified on the basis of linearity into two types. Number one, linear spatial filter. Number two, non-linear spatial filter. So where we are using such a filters in spatial domain, spatial filters use different masks. The meaning of these different masks are nothing but camels, templates, or windows. So there is a one-to-one correspondence between the linear spatial filters and the filters in frequency domain, which we can understand in terms of time and frequency. So such a domains which we are going to be applied here in terms of linear, for the use of linear and non-linear filtering. So here, whenever you are using either linear or non-linear, you may consider such a applied process is here frequency domain filters just for the linear filters. Though we are gone through the 2 or 3 slides which are helping to us in the mechanism of spatial filters, which we understand spatial filters consists of, there are 2 important points. Number one, neighborhood, that is small rectangle based neighborhood process, and number 2, predefined operation, that is performed on the image pixel. So filtering creates a new pixel with coordinates equal to the coordinates of the center of the neighborhood, and whose filtering operation will be valid to get the resultant of the filtering operation. So we understand here the meaning of spatial filter mechanism is 100% depends on either neighborhood or predefined operation that is performed on the basis of image pixel. Next, coming to if the operation performed on the image pixel is linear, then the filter is called a linear spatial filter. Otherwise, the filter is non-linear. So I will repeat once again, though it is very important definition. So the meaning of operation performed on the image pixel is linear, then the filter is called linear spatial filter. Otherwise, automatically the filter is become non-linear filter. So below figure, which we are going to be represents the mechanism of linear spatial filter using at least 3 by 3 neighborhood image, that is 3 by 3 number of rows, number of columns of the image formatted in terms of 3 by 3 neighborhood. So that response of the filter which we are keeping in the g of x comma y of the filter at the any point of x comma y. So it is a meaning of that you are taking an image. Okay, this image may be a 2D image or 3D image. Okay, either 2D or 3D. So x-axis will be your values of the pixels. Okay, so which we are keeping in y-axis as the pixels. Okay, and x-axis will be intensity of the pixels, intensity of the pixels. Okay, so such a intensity of the pixels value which we are keeping in the form of variation of x-axis and y-axis with respect to your domain of the image. Okay, so you are taking this image, okay, in terms of the x comma y. So what do you mean this? This is we are defining as the objective function of f of x comma y. Though your original image in the form of f of x comma y is now transformed into g of x comma y, is the meaning of here we are applied the filter. Then that means we classified the filter into two types. One is linear, another one is non-linear. When will be the linear? It defines that whenever the image pixel is linear, then the spatial filter will become linear spatial filter. Otherwise, it become non-linear filter. That is what we want to understand from here. So, of course, the example which I am taking here, we take the products of the filter coefficients of the pixel values, the image which we are keeping here in terms of x comma y, such values are here varying 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you mean this? This is 3 by 3 is equal to 9. That is number of rows and columns will be 3 by 3 neighborhoods of the x comma y. So the image of the spatial domain which we are defining here in terms of neighbor, this concept is neighborhood. What we have to do, remember neighborhood concept. Such a neighborhood concept in the sense your g of your x comma y is transferred into g of x comma y is meaning of that your f of x comma y is x minus y comma y minus 1 is right now window which we are applied in the value of minus 1 comma minus 1, that is minus 1 comma minus 1 with respect to x and y. Similarly, minus 1 is on x-axis, 0 is on y-axis. Similarly, 0, 0 is x and y. So that means this window value of 0, 0 is nothing but your x-axis versus y-axis value doesn't vary. It is keep constant of that pixel in the neighborhood pixel, in the neighborhood changes of the pixel value. So like that, we can understand the product of the filter coefficients and the image pixels, how it varies to understand towards convert that f of x comma y to g of x y when we are applied the some spatial filter which we may call as obviously linear filter. Otherwise, become non-linear. So that means let us we'll start that observation which I have been discussed with a simple figure, that observe that the center coefficient of the filter is window of x comma y aligns with the pixel at location x comma y, generates the mask of size m into n. So that is assume that where m equal to 2a plus 1. What do you mean? And n equal to 2b plus 1. What is this m? M is nothing but your matrix value, m by n values, your 2D or 3D image. Okay, so where a comma b are the integer values with respect to your pixel values will be vary. Or we also says that if your filter is considered as a linear space filter, nothing but odd filters, your m and n, that is the product of this value. This product of this value, what we are saying that given by the simple expression, that is your product w of s comma t into your f of x plus s plus t. That is s is this and t will be with respect to y. So that x and y varied each of the pixel of w that visits every pixel in the function f. So I am extending that example to understand in detail about how this behavior of the spatial filter will concentrate on converting f of x comma y to g of x comma y. Yes, let us take the original image, okay, maybe a 3D or a 2D image. Such a image, obviously it contains certain image pixels, no doubt. And from the image pixels, we right now started filtering mask. We applied the filter mask. What do you mean that? We are applied the linear spatial filtering process. Okay. So then you transformed, you got that f of x comma y in terms of windows you got, that is your represented windows. And now those all we are going to be represented by the help of filter coefficient, which we represent based on the object function of the particular original image. So you got that pixels of the image selection section under the filter process, which we are going to be keep in the relationship of correlation and convolution. So spatial correlation and convolution will be help us to understand how this filter mask towards to process in terms of pixels of the image section under the linear filter process. So let us take what does it mean correlation? The meaning of correlation means the process of moving a filtered mask over the image and computing the sum of products at each location. At each location, in the sense, you are taking that W 0 comma 0 is one location, and W minus 1 comma 0 is another location, and W minus 1 comma minus 1 or etc. What do you mean this? These are the meaning of at each location you are finding the, that means you are computing the sum of products. That is called correlation. So convolution is the same process as correlation happen, except that filter is first rotated by 180 degrees. What do you mean to understand that? Correlation is also concentrating computing the sum of products, but whereas convolution also same, but here you are keeping only in aspect of 180 degrees, that is x-axis to y-axis, that is f of x comma y. This is what we are writing, 0 to something value. Okay, so this complete variation, this is positive integer, this is positive integer, your concentration, it is negative integer. So that values we are concentrating is here. Okay, positive and negative values of integers we are concentrating. That is, we are keeping into 180. So this is completely 180 degrees. Next, coming to the what does it mean mask? So far I called mask means which is help us to understand the linear spatial filter or non-linear spatial filter from the mask of the image. Actually, what does it mean mask? How can you understand the meaning of mask? Masking is an image processing method in which we define a small image piece and use it to modify a larger image. That means masking is the process that is underneath many types of image processing, including your edge detection, motion detection, and noise detection, which are consisting of 0 and non-zero values. Marks is applied to another binary or to a grayscale image of the same size. All pixels which are 0 in the mask are set to 0. The output will become also 0. So what do you mean to understand that? So because of the mask, your image may want to be enlarged, modify as a larger image or smaller, or the values which we represent in aspect of image of the same size will be modified. That is called a mask. So mask for blurring. So in the process of blurring, we reduce the edge content in an image and try to make the transitions between the different pixel intensities as smooth as possible. So we concentrate that noise reduction is also possible with the help of blurring, that we extended in terms of forcing or faking eye contact during conversations, that imitating smiles and other facial expressions, mimicking gestures, hiding or minimizing personal interest. So developing a reportrait of rehearsed responses to your questioning of the mask for blurring. So such a one we extended in terms of general classification of spatial filtering, that we also says smoothing spatial filtering. Smoothing filter is used for blurring and noise reduction in the image. Blurring is pre-processing steps for removal of small details, and noise reduction is accomplished by blurring. So the types of smooth for spatial filter with respect of blurring, we also says that linear filter is nothing but mean filter. Order statistics filter is called nonlinear filter. So nonlinear filter is always we keep on the order statistics filter. So what does it mean mean filter? Linear spatial filter is a simple the average of the pixel contained in the neighborhood of the filtered mask. That is, the idea is replacing the value of every pixel in an image by averaging of the gray levels in the neighborhood defined by the filter mask. That is what we are keeping in terms of multiplied by higher value than average filter value. So that means there are two types of mean filter, which is number one average filter, second one is weighted averaging filter. Averaging filter, it is used in the reduction of the detail in image. All coefficients are equal. Number two, weighted averaging filter, in this pixels are multiplied by different coefficients and the center pixel is multiplied by a higher value than the average filter. That are the two types of mean filters. Whereas order statistic filter, which we called as here nonlinear filter, nonlinear spatial filter. So which is it is based on the ordering the pixels contained in the image area encapsulated by the filter. So it replaces the value of the center pixel with the value determined by the ranking result. Edges are better preserved in this filter. So types of order statistics filter also we define into two types. Number one, minimum filter, and number two, maximum filter. What does it mean minimum filter? Minimum filter means it is the 0th percentile filter in the minimum filter is value of the center is replaced by smallest value in the window. Whereas maximum filter, that is 100th percentile filter, is maximum filter. Here the value center is replaced with largest value in the window. So the difference is very smallest we call minimum filter process, and largest we called as maximized filter. So far we discussed about the order filtering processing. We also can extend that to understand such a order statistic process in the view of median filter. Here you are consider each pixel in the image is considered. The first neighboring pixel are sorted and original values of the pixel is replaced by the median of the list. The sharpening spatial filter we also called as derivative filter. The purpose of the sharpening spatial filter is just opposite of the smoothing spatial filter. Sharpening spatial filter opposite is the smoothing spatial filter. It focuses on the removal of blurring and highlight the edges is called a sharpening spatial filter. So it is based on the first and second derivative orders we defined and developed the sharpening spatial filter. So first order derivative means must be 0 in the flat segments, must be non-zero at the one set of a gray level step, and must be non-zero along ramps. So these are the first order derivative filtering which we are using under the sharpening spatial filter process. Whereas this first order derivative is simply write 1D is given by f dash of f of x comma f of x plus 1 minus f of x is the first order derivative. Whereas second order derivative is also we concentrated from 0, that is we simply say must be 0 in the flat areas, must be 0 at the one set and end of ramp, okay, and must be 0 along ramps. The second order derivative simply we called here it is 2D. The spelling mistake. This 2D is given by f double dash uh, f of x plus 1 plus f of x minus 1 minus 2 f of x. So I hope you understood that today topic is one of the very important topic we called as a spatial filtering process. So such as spatial filtering where we can use that what how can you classify it, and once you classified how can you extend it that into apply to the a spatial filter based on the grade level image. And if you have grade level image and neighborhood pixel principle we applied, and we got external knowledge about this topic. I hope you understood the complete topic, the simple concepts which we called as the fundamentals of spatial filtering. You need to refer much more about this topic. Kindly go through these topics, these references textbooks, and you may get much more knowledge also. I am really very thankful for your patient listening, and we are going to have one more topic which we are applying this concept in terms of mathematical way and solving some problems. I'm really once again thank you so much for your kind attention and patient listen. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.